Hi, welcome to UpNLC Solutions. Today we're going through 2014 Ordinary Level Paper 2. This is question 8, which is mostly about trigonometry, and there's a little bit of area thrown in there as well. The first part of this question gives us a picture of a wind turbine and tells us that the three blades of the turbine are equally spaced and they're 65 meters long each. We have to write down the size of the angle between two blades. Looking at this diagram, you can tell that the whole way around is going to be 360 degrees. If the three blades are equally spaced, then they have to each be a third of that 360 degrees. So 1/3 times 360 gives you 120 degrees. The second part of the question asks us to find the area of the disk traced out by one full rotation of the blades. So ignoring that last bit of diagram, there's now a disk traced out by the ends of the blades, and we're asked what is the area of that disk. Well, the area of a disk, you know from your Formula and Tables book, is pi or squared. We know the radius because we're told that the blades are 65 meters long, and so this is pi times 65 squared. To the nearest whole number, that is 13273, and that's going to be meters squared. The third part of this question asks us to find the area of the triangle formed by joining the tips of the three blades. So we've got to join the tips of the three blades in our diagram and find the area of this resulting triangle. There's a few ways to do this. You could start trying to figure out what are the lengths of this triangle. The easiest way is probably to consider that this big triangle is made up of three smaller ones. And you make those three by joining the vertices to the center, like this. And those three are identical. It doesn't quite look that way because of the way the perspective of the diagram is, but these three triangles are identical, and we know a lot of information about them. We know that two of the sides are 65 because those are the lengths of the blades. That's 65. That's 65. We know that this angle is 120 because we worked that out for the first part of this question. And based on that, we can actually work out the area of one of those triangles. From trigonometry, we know that the area of a triangle is given by a half times two side lengths multiplied together, 65 times 65, times the sine of the angle in between those two sides, which in this case we know is 120 degrees. We also know that there are three triangles in total, so this whole thing just gets multiplied by 3. And all you have to do is pop that into your calculator, and you get 5,488, and those are meters squared. The last question in part A tells us the expected lifetime of the turbine is 25 years. The turbine operates 31% of the time, and it tells us how often the blades rotate, 15 times per minute, and we have to find the number of times the blades will rotate during the lifetime of the turbine. And this one requires a little bit of dimensional analysis. So we start with 15 rotations per minute, so rotations per minute. And we have to work our way up to years because we're starting with 25 years. So we go from minutes to hours, so that is 60 minutes per 1 hour times 24 hours per 1 day. It says to ignore leap years, so we're going to assume it's 365 days per 1 year. And this tells us how many times it's going to rotate in 1 year. But we don't just want 1 year, we want 25 years. So 25 years. And that gives us 197,100,000. But the turbine only operates 31% of the time. So we have to take 197,100,000 and multiply it by 0.31, that's 31% in decimal form. And we end up with 61,101,000. Now it says to write the answer in this form: a times 10 to the power of n, where a is a number between 1 and 10 and n is an integer. The a part is just telling us that we write out the same number, but we put a decimal after the first significant figure, so 6.1101. We don't include zeros that come after the last significant figure unless they're after a decimal. The way we work out the n is we essentially just count the number of digits and subtract 1. So this is 1, 2, 3, 4, 5, 6, 7, 8 digits. Subtract 1, and that becomes 10 to the power of 7. In part B, we're told about Grones, who's trying to measure the height of this wind turbine. We're told about some measurements that she takes. She knows she's 100 meters away from the base of the wind turbine, and she measures an angle of 60 degrees from the ground up to the top of the wind turbine. And what we have to find is this height. The wind turbine is vertical, so what we're allowed to assume is this is a right-angled triangle. And with that information, we're allowed to use things like Pythagoras' theorem and the trigonometric identities. The one that applies here is one of the trigonometric identities, tan, because we have an angle 60 degrees. We are looking for the opposite side, and we have the adjacent side. So it's the only one that contains the three pieces of information that are involved in this question. We have tan of 60 degrees is equal to the opposite side, which is h, divided by the adjacent, which is 100. And so h becomes 100 times tan of 60 degrees. And that turns out to be 173 meters, correct to the nearest meter. In part C, Grones recognizes that her measurement of the angle might not be totally accurate. Apparently she's read somewhere that the height she should have gotten was 154 meters. We're now to assume that she measured the 100 meters from the base of the turbine to where she was standing accurately, so that is 100 meters. And we're asked to find the actual size of the angle at B. What she measured to be 60 degrees, we now have to find out the exact value based on this new information. So let's draw out our new triangle. We have this angle, let's call it angle B. We have the height this time, which is 154, and we have the adjacent side, which is 100. We can use the same trigonometric ratio because this is still a right-angled triangle. Nothing's changed about that. So we have tan of this angle B. We don't know what it is. We know it's equal to 154 divided by 100. To get B on its own, we need to bring tan over the other side, in which case it turns into an arctan, or an inverse tan as we sometimes call it. It's 154 over 100. And that turns out to be 57 degrees, correct to the nearest degree. The very last part of this question asks us to find the percentage error in Grones' measurement of the angle of elevation correct to one decimal place. So the percentage error is given by the actual error, that's 60 minus 57. So she measured 50, it should have been 57. Divide it by the actual value, that's 57, and multiply it by 100 to turn it from a proportion into a percentage. That's 3 over 57 times 100. And correct to one decimal place, that is 5.3%. So that's the question finished. Thank you very much for watching, and hopefully I'll talk to you again in the next episode.